Okay, for the rest of the examples, the directions say to solve the logarithmic equation, be sure to reject any value that is not in the domain of the original log expressions and give the exact answer. Okay, so some of these I'm going to be using different techniques than you've seen in the previous problems. Number 8 says log base 3 of x equals 4. If you have just one log in your equation, okay, we know we can't rewrite these to have the same base or same log, but I can convert this. Okay, remember our conversions to exponential form. My base in my log is the base, so this means 3 to the 4th power is equal to the argument, which is x. So 3 to the 4th power equals x. That means x is equal to 81. So this is an example where we're converting to exponential form to solve. And so I can do the same thing on number 9. I have log base 4 of x minus 3 equals 1. So again, if I just see one log in the problem, I can convert to exponential. This means 4 to the 1st power equals x minus 3. So 4 to the 1st power equals x minus 3. So that's just 4 equal to x minus 3. So add 3, and that would give me x is equal to 7. Okay, on number 10, notice we have two logs in the equation. Log base 4 of x plus 3 plus log base 4 of x minus 3 equals 2. So we can use some of the properties that we talked about in section 3.3, where we have a sum. I can condense these two logs into one, so it would be log base 4 of a product, okay, of x plus 3 times x minus 3 equals 2. Okay, so what good will it do if we condense it to one log? Well, that means I can then convert, just like we did up here on number 9. It would be 4 to the 2nd power is equal to x plus 3 times x minus 3. Okay, so that gives us an equation we can work with. So I would have 16 equals, when we multiply these out with the full method, it would be x squared minus 9. So we can solve this by setting it equal to 0 since it's a quadratic. If I subtract 16, I'm going to get x squared minus 25 equals 0. That's going to factor as x plus 5 times x minus 5 equals 0. And remember, we can set each one of those equal to 0, which would give me the solution of x equals negative 5 and x equals positive 5. Okay, let's go back and think about the domain for just a minute. It says reject any value that's not in the domain of the original expression. Okay, well, if I go back and check these, what's going to happen if I plug in a negative 5 in the place of x? That's going to give me an argument that is negative, okay, which we said in the beginning of this section, that cannot be a negative. So I would reject the negative 5 and say that my solution is only just the x equals positive 5. Okay, number 11, we have natural log of x equals 3. Well, one thing we can do whenever you have a natural log, remember that is, all that is a log of base e. So I could rewrite this as log base e of x is equal to 3. So now it's written as a log, a single log that I can convert to be x to, or e to the 3rd power is equal to x. Okay? And so we could go to the calculator and get a value for that, but on all of these, they just want exact answers. So it's just e to the 3rd power.